Yes, sir.
Okay. So serial interface, and right now we are talking about the introduction, and afterwards, yeah, and as well as how the synchronous data will be transferred using the clock signals, and here the data rate will be around 10 Mbps per second. Okay. So serial interface, like I said, so it's a synchronous one. So data will be transferred using the clock signals, and it was developed by the Motorola. Same thing here given, and the data communication will be made using the master and slave mode. Okay, so if two devices are communicated using this serial peripheral interface, so there will be one will be act as a master, and the remaining will be act as a slave. Okay, so if we want to transfer the data. Okay, and as well as there will be some protocol in order to transfer the data. Initially, like a USB, it will like a plug and play, but here we required some procedures in order to do the communication. And one more advantages is here we can able to connect the multiple devices. So one will be act as a master, and the remaining all will be act as a slave. It's not a one-to-one communication, it is one to many communication. So one device will be act as a master, and the multiple devices, so that will be act as a slave. And the data transfer will be done using the chip select. So chip select means to whom I want to transfer the data. So based upon the chip select, we will see that chip select pin. Based upon that, I will select the particular slave only. After that, I will transfer the data. And as well as while transferring the data, the master will send the data. It may be a 8-bit or it may be a 16-bit to the slave. And similarly, the master also receive the data from the slave, but the slave can able to send only 8-bit data. So here they represent using the byte. So it representing 1 byte is equal to 8-bit. So the slave can able to send the 8-bit data only maximum, but the master can able to send up to 16-bit, minimum of 8-bit, up to 16-bit it can able to transfer the data serially. Okay. And here the data rate is representing, so maximum data bit rate will be 1/8 of the input clock rate. So 1/8 in the sense what it represents in the sense 1 by t. So time it takes to transfer one data is it is representing the 8-bit, right? So 8-bit means 8 clock pulse it is required. So here they're representing for 8-bit data it requires 1/8 of the clock rate. And as well as there will be always a master. So if you are connecting interconnecting everything, the one will be act as a master and the remaining will be act as a slave. If you go for the CAN bus, so there won't be any master and slave connections. It will be a distributed one. So everything, each and everything will be make a interface, make a communication without act as a master or as a slave. It is a centralized one. Sorry, it is not a centralized one. But here, the serial peripheral interface, it is a like a centralized one. It representing there will be one master, and the remaining will be all will act as a slave. And for communication purpose, there no need of decoding. I mean the address decoding. Why? In the sense we having a chip select. So particularly I will select a particular slave, and then I will make the communication. But if you go for the RS-232, otherwise CAN versus, so there will be address for each and every devices. So it will compare with the address. After that it will come do the communication. But here it is not like that. It will make the device, I mean the master will send the signal to the particular slave to whom it will communicate. Okay, so after it selecting that particular slave, then it will transfer the data. So here there is no need of the address decoding. Okay. And as well as if the master want to send the data, it will send using the clock pulse. And as well as clock pulse will make the slave to be active. And so suppose it is want to acquire any information, the acknowledgement from the slave means it will make the slave to send the data, so that the slave will send the data and master will receive the data. And so here the two pins are available. So one is master output slave input, and master input slave output. So these are the two pins are available. So it will do the communication in one way. Okay, so first if you go for the MOSI, the master will act as the output. It representing, it will send the transfer the information to the slave. So slave will accept the input. So that's why it is named as master output slave input. Okay, and as well as another one is master input slave output. So in this, slave will produce some output, it will transfer to the master, so the master will take it as a input. So these are the two lines which is using for communication purpose, and as well as it's a unidirectional. It's a unidirectional, it's not a bidirectional. Why? Because in MOSI, so there will be only one-way communication. Similarly, we are using the another line for receiving. Okay, so it will act as a simplex or duplex. Do you know what is a simplex, duplex, or I mean half duplex and full duplex? So it will work as full duplex one. Why? Because we having a two separate line, we can able to send and receive the data. Okay. So here they are representing that four pins. So one is a master output slave input, and a master in slave out, and a serial clock. So it's a synchronous communication. So surely we require the serial clock, and the last one is a slave select. So I told you, so if multiple slaves are connected, means I will use the slave select by making it's an active low signal. So low in the sense, once I given a 0 to that particular slave, it will become activate. After that, it will be ready to receive the data. Okay, and the pin descriptions they are given. So serial clock, SCK, so it will act as the input as well as output. Why? Because if two devices are connected, so one will be producing the clock signal, the another will be receiving the clock signal, but both the pins are same only. Okay, so here the serial clock is a bidirectional one. It will act as the input as well as it will act as the output. Okay, and and as well as if you having, I mean, if you want to transfer the data, the master will send the clock signal to the slave. Slave won't produce any clock signal, it won't send. Only if the master want to make the communication with a particular slave, master will generate the clock, and as well as it will uh, activate the slave by giving the clock pulse, and it will decide whether the slave has to work at active high or active low, and as well as this will make the three state. So tri-stated, you know, one is a 0 and another is a 1. The tri-state, the third state is nothing but high impedance. So we are not connected to a 0 or we are not connected to the ground. So it is not shorted with the 1. I mean 1 representing high voltage, or the line is not shorted with the 0. It representing the ground. So it will be open circuit. So open circuit representing a high impedance state. And the clock pulse will be active. So when, in the sense, for making the data transfer. So once you want to make it send any data in your communication line, I will generate the clock so that it will become active. And next is master input, slave output. Like I said, so it will act as the input and output. And if MISO is activated, and it will be unidirectional. So it's one-way communication will be done during, suppose if master wants to send the input, I mean a master want to take the input from the slave. Okay, and as well as the serial will act as, I mean, sorry, the slave will act as a, I mean, in taking a producing the output, and the master will act as taking as an input. So that is a function they are given here. And if the slave select, I mean SS is not selected, means there won't be any communication. So it will be like a high impedance state. So surely if we want to communication, we require the chip select will be activated. So then only we can able to do the transformation. Similarly for MOSI, here the master will send the master will generate some output, and it will send the transfer the data, and the slave will receive the data. So master will be act as the output and slave will be act as the input. So here also we have to give the clock pulse as well as we have to make the chip select and the slave select or chip select. So slave select is just input signal. So master will make a low signal. So it will send the 0 to any one of the slave. So on the time the slave will act as, I mean, it will be active and then it will ready to do the data transfer between the master and slave. So active low in the sense I want to make a 0. Okay. So why this is available in the sense if I connected the multiple slave to this particular master, the master want to select any one of the slave in order to do the communication. So in order to select it, we are using this slave select pin. So these are so these are telling about a particular chip, but in our syllabus we are not going to talk about one of the processor. So we will go for the communications, how the communication will be done. Okay, and the so like I said here also mentioning the same. So active low signals I want to give to the any one of the slaves in order to permit it to transfer the data or receive the data, and we can select whether it will be active low means it will be you can able to make a low voltage, otherwise the falling edge. So falling edge means from high to low. So previously I told what is the falling edge, what is the active edge. It's in the sense positive edge triggering, negative edge triggering. So positive edge triggering means when the transition going from 0 to high, so there is a positive high edge triggering, and the negative edge triggering representing the falling edge. So negative means from 0 to, I mean sorry, what, so from 1 to 0 it's coming down, so negatively it is falling down. On the time also I will make the slave activated, and here they are using the interfacing between the ICs, the MAX 1242. So in MAX 232 we seen in order to make the communication from RS232, here we are using the MAX 1242, and so and as well as the analog to digital converter. So you know what is the purpose of analog to digital converter? In order to transfer the analog signal which is bounded with time to unbounded data. So digital is cannot be able to mention using the time. Why? Because it's a discrete one. Analog is a analog signal is nothing but analog signal, and the discrete signal is nothing but the digital signal. Okay, so with respect to the time, the analog signal will be vary, but digital for a particular duration the output will be same, but analog is not like that. So each and every time second, microsecond if you take, millisecond if you take, the way data will be vary. So analog one. So digital means it will be constant for a particular duration. Okay, and let's see the operation here. You can able to see it's like a single master and single slave are communicating each other. So first so both the 4 pin is common, but which will act as a master and which will act as a slave, that will be vary. If you look at this here, the master, one of the SPI serial peripheral interface will act as a master, and the another one will act as a slave. So I told you that if any one device is acting as a master, that only generate the clock pulse and given to the slave to do activated. So that if you see that, look at the arrow mark from the first pin, yes, clock, serial clock. So it is arrow marked, I mean the direction is going from the master to slave. Okay, and another one is MOSI. So master output, slave input. So master is producing something and slave will accepting it, representing master will transfer, slave is receive. So it will be act as a receiver. So the arrow mark is from master to slave, and the MISO. So slave will sometimes slave will produce some acknowledgement, it will send the data. So that will be done using the master input, slave output, so that the data transfer will be from slave to master. And the last one is chip select. So master has to select the chip, so that's why the direction is from master to slave. And chip select or slave select. Okay, so this is how they will do the communication. So first what it will do in the sense, it will make the clock pulse given to the slave. So it may be a falling edge, I mean negative edge triggering. So once it is given, the slave become active now to transfer or receive the data. Okay, and here the chip select will be -1, but only one in the sense it is not required. If you are connecting the multiple slave, the slave select pin will be required. Okay, And so there are two types of communications. One is a typical serial peripheral interface bus, and master and independent slave, like we seen right now. And second one is daisy chained serial peripheral interface. So let's see what is the difference between the typical and daisy chained serial peripheral interface. So look at this typical serial peripheral interface. So here I connected only one master, and remaining all will act as a slave. And if you look at the clock pulse, so it is given common from master to slave 1, slave 2, slave 3. Three slaves are available. So look at the clock pulse, it is a common pin, and as well as the master output to slave inputs are given using the common pin. Okay, and similarly, the master input slave out, master in slave out is also given in a common pin. And only thing is the chip select will be vary. So here we required three slave. So for three slave, not to make it any one of the active, I'm making a three pins available here. So one is connected to the first one, and second pin, the slave select is connected to second one, and third pins of slave select is connected to the third devices. Okay. So if I want to do the transaction, first what I will do in the sense I will activate the clock pulse. So it will be given to all the slave. So all will be ready, but in order to make the transaction, I will select the one of the slave using slave select. So if I want to make the transfer, so the S1 will become low. So if I become S1 to low, the first one will be activated. And if I given, for example, I given a second one to be low and remaining all high, in the sense the second will be activated. After that, if I want to transfer, I will I will send the data using MOSI, so that the communication will be happen. And similarly, if I want to receive, means I will receive the data through MISO. Okay, so this is how the communication is there. And as well as check the pins, how the pins are connected from master to slave. So these are the typical serial peripheral interface. And so daisy chain, so it's a different one. So if you look at this, the input, MISO, master in serial out, sorry, slave out. So pin is connected in different manner. So first slave is producing some output that will be given to your second slave. Look at this, the MISO of the first one is connected to the MOSI of second one. Similarly, MISO, master and slave output of a second one is connected to the third one. So this is the daisy chained serial peripheral interface. So this is how the communication will be happen, so that the slave will be able to communicate each other. After that, it will make connection to your master. So it will look like the ring structure. So master can able to communicate with the first slave, and the first slave will communicate to the second slave, and the second is communicating to the third, and the third MISO is connected to your the master. So again, it will like a ring structure. So circular manner it will transfer the data. Okay, and if you look at this, the slave select will be common. So I will activate all not to do the communication. Why? Because if any one is activate in the sense, I can able to transfer the data between one only. So that's why it is in a ring structure. So if I want to transfer to the third slave, I will activate all the clock pulse commonly, and as well as I will activate all the slave. Only thing is I will transfer the data through master through the slave 1, slave 2, after slave 3. Suppose if I want to connect with, communicate with master to slave 3. So there won't be any direct communication. All of you clear about this, guys?
Yes, sir.
So simple connections. So difference is, if you look at this one, typical one, so individual slaves select will be there, and there will be a common MISO and MOSI will be common for all the master and slave. But if you look at this one, the slave, the daisy chained serial peripheral interface, the slaves pins are interconnected with the master in a circular manner. So it will be like master to slave 1, slave 1 to slave 2, slave 2 to slave 3, and again back to your the master. So what I explained, here they given it using the wordings. Yeah. So these are the important points which you have to remember. So thing is here, so slave can able to send the data. In some cases, the acknowledgement cannot be happened in this serial peripheral interface. Whether the slave is received the data, I mean the receiver is received the data. Sometimes the acknowledgement cannot be done, and as well as the flow control is not available. So what is the flow control, guys? What is the flow control? What is flow control? Guys, what is flow control? Anyone? Flow control. Flow control is nothing but the speed of operation, the data bits per second. So if it is transferring fastly, means it will transfer. There won't be any control. What is the need of flow control? Means I told you, for interfacing with the fastest device with your slowest device, it requires the flow control. So it will reduce the speed of operation. The data rate will be slowed down one by one, bit by bit. It will transfer. If I connected, again I'm telling the same example, if I connected the computer will transfer the data in terms of gigahertz frequency, but that printer cannot able to accept that much speed, so it will works under the megahertz only. Why? Because the inside chip will works in terms of megahertz, so there won't be any flow control. So that is representing that the speed of operation cannot be monitored and controlled. Okay, so suppose it is transferring 10 bits per second, I mean 10 megabyte per second, the receiver is can able to receive the data in 1 megabyte only. So what I will do, in the sense, I will make the buffering is much temporary storage. I will make the delay, so that in that process, one by one, I will transfer the data. Until that, it will store in the temporary storage. Okay, so receiver will receive the data at 1 mbps per second, and once it is completed, means that the register will become empty. After that, the data will be loaded into the buffer again. The entire 10 MB data will be loaded here, and one by one it will transfer to the printer. Okay, so that is nothing but the flow control that is not existing in this mechanism. And as well as the master doesn't have a knowledge that slave is available or not. Why? Because there won't be any acknowledgement, in the sense, if I transfer the data, if slave is exist or slave is not exist. So how come it will know? So that is another drawback of here. And there is not any particular addressing scheme. So addressing scheme, in the sense, it's like a point-to-point communication. So I will select any one of the slave and I will transfer the data. That's it. So communication address is not available. Now to make sure that if anyone is tapped on, that means anyone can receive the data. So if it is having any devices having particular address, means it will receive that particular data which is having that particular address. If it is not having any address, means I will connect any other devices into that communication. I will receive the data, I will transfer the data. So addressing scheme is not available and not defined any maximum data rate. So data rate will be may vary. So here there is no the constant data rate and all. So maximum we see in the 10 Mbps, but it will be vary. It's not a constant one. So data transmission, how it is occurring. So here the two devices, master and slave, are there. The clock signal is given and MOSI is given, MISO is given. So here you can able to see they will use the shift register. So serial in, serial out, shift register. So how it will work, serial in, serial out, which is studied in digital electronics. Serial in, serial out. Guys, explain
Yes,
how
sir.
this serial in, serial out.
Sir, சரியா ஞாபகம் இல்ல சார்.
बोल serial in, serial out. If you look at this, take a register which is available in master, the data will be transferred in 1 bit towards MOSI, and the input is given to your 0. 0 is nothing but your input. There I will give the input, and the output from 7th bit, right? 0 bit, 7th bit is there, and input is one by one it will send. So initially just think ma. So think everything is empty, every bit is empty. So first what I will do, in the sense I will transfer the 1 bit to your first one. So first I am transferring the number 7. Okay, so that 7 will be in first location, and shift register, I am using the shift register, right? During the second clock pulse, it will, that data which is available, that will be shifted to the second one. Okay, so the 7 will be moved to the second position, and first will become empty. On the time I will send the second data. Okay, so serial transmission means here I am going to send totally 8 bit. So 1 bit, I mean from 0 to 7, totally 8 bit I am going to transfer. So now I am transferring the second data. So second data is nothing but the 6th one. So 6 will be transferred to first location, 7 will be moved to second location, and after that I am transferring the number 5, so that in third clock pulse. So if I am transferring the 5 to the third clock pulse, so that the 7 will be moved to the third position, in second position 6 will come, and first position 5 will come. So this is how the shift register will work. During the first clock pulse, the data will be available in the first register. During the second clock pulse, it will be moved to the second register, and during the third one, it will move to third register, and so on. Okay, it will be in circular manner. So the same way, if you look at this here, suppose make a slave is empty, and make the master is available from 0 to 7 bit. So now I am going to make it, I mean transfer the data from master to slave. So master is producing, I mean transferring, it will be act as a output, and slave is going to receive, it will be act as a input. So what I will do, I will transfer the first I mean last one. Last, what is the number? What is the number of lost in master register?
7.
It's a 7 1. Okay, so 7 will be
Yes, sir.
moved to first location of your slave. 7 will
Yes,
be
sir.
moved to first location of your slave during the clock pulse of first one. So serial clock will be generated. So first clock pulse, I am transferring the 7. Okay, so after next clock pulse, what it will do, I mean the 7 become empty. So this will, I mean 0 to 6 will be moved to next location. So in first position of the master will be empty, and the second position onwards it will be started with 0 to the last will be available 6 1. Okay, and during the next clock pulse, the 6 will be moved to your slave. So on the time what it will do, in slave, the first position previously it was 7, and in the next clock pulse 7 will be moved to second position, and the 6 will come to your first location. So likewise for 8 clock pulse, the 8 bit will be transferred to the slave. Okay, and similarly, if the slave want to transfer the data, to the master, so look at that, it is connected with 7th position to your the 0th position of your master. So 7th position of your slave is connected to 0th position of your master. Okay, so how it will do, so first it will send the 7, after that it will send the 6 5 4. So it will complete the data transfer. When it becomes 0, it is transferred to the master. So on the time you may get the data. So it is like a ring structure. Okay, so it is connected in a circular buffer. It is called as a circular buffer. So the data is transferred using the circular manner. Okay, so this is how the data transmission will be done in serial peripheral interface. All of it clear?
Yes, sir.
And so look at this, they're given the frequency of oscillation. So the range of the frequency is 1 to 70 megahertz, and that, I mean the clock pulse which is generating, it will be in the range of 1 to 70 megahertz. Okay, and similarly they given the slave select will be have to make active by giving a low value. Low in the sense the grounded. You have to give a 0 value, then only you can able to do the transfer. And as well as, like I said, the full duplex communication protocol here we are using. So we can able to transfer as well as receive the data. If you look at this, if the master wants to send, it will transfer simultaneously. Slave also can able to do the transaction. So at a time, the transmission as well as reception can be done using the two different line. Okay. Suppose if we are having only one line, means first I will do the transmission, and in next, next after completion of transmission, next clock pulse I will use the reception. So, okay. So that is half duplex, but here it is full duplex communication. It will work. So master will be sent and slave will be read. So using the MOSI, and as well as master will be reading by using MISO. Okay. So, and as well as the transaction will be done using the 8-bit between each other. So master can able to transfer using a 16-bit, and the slave will be able to transfer only the 8-bit condition. And if you can able to see, the circular buffer is works as a ring structure, and as well as we seen in a daisy connection, in that also the data is transferred in a circular manner. So that's why they represent the connection is in the ring topology. You remember the ring topology, how the transmission will be done using the ring topology, like a same one, like a circular buffer. Okay, in a circular manner, each and every devices are connected. And once you transfer the receive the data, afterwards the master or a slave, so which is linked with the memory, will do the read or write operation. Okay. And so here the last point representing that, suppose if you want to transfer the bulk of data, so first will be 8-bit data will be loaded and it will be transferred, and in next time cycle it will load it with the new data and do the transaction, and again it will load the another new data, third set of bit. So a set of bit representing a 8-bit. So likewise the transmission will be done, and the data will be transferred. So this up to this the operation will be over. And advantages, so what are the advantages? In the sense the full duplex communications are occurring here, and as well as the higher throughput. So throughput representing the same, the speed of operation. Successfully how much data is delivered without any loss or without any error, with lowest utilization of a resource. So did you understand what I mean? Successfully transferring, successfully in the sense there won't be any loss or there won't be any delay. So, and transferring the data with particular time duration without any loss, and as well as with using a low resource. So low resource means suppose I want to travel, in the sense it's enough for me. Suppose I want to travel a 10 kilometer. Which one is efficient, whether I'm using a bike is efficient or I'm using a public transportation is efficient one? Which is efficient one? Hello?
Yes, sir.
Which one is efficient?
Sir, question what is சொல்லுங்க sir?
Are you listening, guys?
Listening sir.
If
அந்த time கிட்ட கரெக்டா break ஆயிடுச்சு sir.
suppose I want to travel from one place to another place, it's around 10 kilometer. So I want to go, in the sense I'm using a bike is efficient or I'm using a public transportation is efficient one?
Sir, public transportation sir.
So public transportation is efficient one. Thing is, I moved from one place to another with low cost. So that is nothing but using the low resource, I am transferring the data. Okay. So that's why higher throughput than the I square C. So integrated circuit. So when compared to that, this is a best one. And as well as no limited to 8-bit. So like I said, first it will load it with the 8-bit transferred, again it will load with another 8-bit transfer, again it will load it with another 8-bit. So here there is not be any limitations. Okay. And so message size will be any one, and I mean it is not a precise uh, data rate. I mean, if we see this frame structure, for one bit itself, it takes a 13 frames. I mean, 13 bit it will take. For suppose I want to transfer 8-bit data, along with that, sorry, not at 13, 11. So along with the 8-bit data, start bit, stop bit, priority bit, everything will be included, and that will be transferred. But here it is not only I am sending the 8-bit data, so it's a advantageous one, as well as it works under low power consumption. So these are the advantages, and disadvantages already we seen the same thing. So it so one is the hardware. There is no any hardware for flow control, and slave doesn't do any acknowledgement. And multi-master is difficult to implement. Why? Because in some devices, a mini master can be active. You see in CAN bus, CAN. So it will act as a master, it will act as a slave. But here, only one master, the another will be a slave one. Okay, so that is a disadvantage one, and this will be used for short distance only. And similarly, it requires the more pin when compared to your I2C. Okay, so these are the disadvantages of your serial peripheral interfaces. And the application where we are using. So So it is used in converters, unlock to digital converters, digital to unlock converters we can able to use, and it will be used in the memories in order to do the transfer. I mean writing and reading the data. So there we will use the serial peripheral interface, and some sensors also will be connected in serial peripheral interfaces, like temperature. If I want to calculate the temperature, if I want to calculate the humidity, if I want to measure the pressure, so in that sensors will be there, that will be connected with your the serial peripheral interface in order to do the do the transaction. Why? Because sensor will do read something and it will produce some output, but we need to transfer in normal format. So that in that case, I want to connect the SPI, and as well as I can able to use in the real-time clock. Okay, so why? Because the real-time clock is used for measuring the task, and as well as it will give the exact time, like 24 hours it will give. And something like a potentiometer, the LCD controller, UART, so universal asynchronous receiver transmission, and the USB controller. So nowadays we are using the USB, right? So in some small devices, everything comes under the USB. So there I will use the SPA and the CAN controller and amplifier. So these are the some few applications of your serial peripheral interfaces. Guys, any queries?
No, sir.
Okay.